सो वेलकम बैक। सो पिछले लेक्चर में मैंने बात बताई, पिछले दो लेक्चर्स थे जिसमें सेंट्रल फोर्स प्रॉब्लम की हमने बात की। हमने बिगिनिंग की गैलीलियो से, एंड देन आफ्टर गैलीलियो हमने थोड़े सा अरिस्टोटेलियन व्यू की बात की, एंड देन वी टॉक्ड अबाउट न्यूटन एंड देन कैप्लर्स लॉज, जिनका कहीं ना कहीं रोल रहा। और न्यूटन ने जो ऑब्जर्वेशन थी, न्यूटन की ऑब्जर्वेशन दैट वाई एप्पल इज फॉलिंग फ्रॉम द ट्री टुवर्ड्स द अर्थ, वाई, और वो क्यों ऊपर नहीं जा रहा था। और दूसरा कि एक और बड़ा इंपॉर्टेंट क्वेश्चन था कि जो मून की रोटेशन है अर्थ के अबाउट और जो एप्पल नीचे गिरा, क्या वो सेम फोर्स है या अलग अलग फोर्सेस हैं। तो उसका जवाब कहीं मिला कि कोई सेंट्रल फोर्स थी या सेंटर की ओर चीज़ें आ रही हैं, और एक लॉ ऑफ ग्रेविटेशन भी दिया उन ऑब्जर्वेशंस को करने के लिए। या ये बोल सकते हैं कि जो हमारे पास सेलेस्टियल मोशन था या टेरेस्ट्रियल मोशन था, उन दोनों को कंबाइन करने की कोशिश की, और उसमें जो लॉ न्यूटन ने दिया, सो व्हाट वाज दैट लॉ? That law is this one, that is not G, but force of attraction between these two objects will be G m1 m2 over r square, and it is the unit vector along which the force is acting. And here negative sign basically indicates the attractive nature of the force, right? Then, so it is the Newton's law of gravitation. इसकी हम सिंपली यहाँ पे बात कर रहे हैं, ठीक है। इट इज द न्यूटन्स लॉ ऑफ ग्रेविटेशन। इसी तरह से और भी लॉज हैं हमारे पास। फॉर एग्जाम्पल, सपोज मेरे पास अगर टू चार्जेस हों तो उनके बीच में जो फोर्स होगी, व्हाट वाज दैट फोर्स? दैट फोर्स कैन आल्सो बी रिटन एज लाइक दिस, दैट इज that this is gravitational force, and say it is Coulombic force. Means if two charges are there, q1 q2, and they are separated in vacuum, then the force between them is proportional to q1 q2 over r square and multiplied by constant of proportionality 4 pi epsilon naught r square. And depending upon the whether the q1 and q2 are both positive or negative, then its sign will be positive. And if both q1 and q2 are of opposite nature, then this force is a attractive in nature. So if I try to look at these two forces, then these two forces seems to be central forces. These are the central forces. So because in the earlier lecture I didn't talk about these two laws, and these are the central force problems basically. और अगर मैं इन दोनों लॉज को सम अप करना चाहूँ, मीन्स इन ए सिंगल लॉ, देन हाउ दीज टू लॉज कैन बी रिटन एज? दीज टू लॉज कैन बी रिटन एज एफ इज इक्वल टू, इट इज प्लस माइनस सी ओवर आर स्क्वायर एंड आर कैप. सी इज ए सम कांस्टेंट. फॉर एग्जाम्पल, हियर द charges are constant, but r keep on changing. So what does it mean? That means when the two objects are away from each other, then the force between them is a very big, and when they are more closer, then the force is stronger. Whether that force is attractive or that force is repulsive in nature, because force is inversely proportional to, or in other words, I can say that force is inversely proportional to 1 upon r square. So this is the standard form to write down the central force. Okay, so now here my objective in this particular lecture is the central force motion as a one body problem, because here we are talking about the two bodies, whether these are the material objects whose mass is m1 and m2, then force between these two can be written like this. And similarly, if when q1 and q2 are the two charges with us, then the force between these two charges can be expressed in this way. So that means this is a two body problem. Now what we will do, we will reduce this two body problem into a one body problem, and the central force motion को अब हम वन बॉडी प्रॉब्लम में एक्सप्रेस करना चाह रहे हैं. सो व्हाट वाज द आर्टिकल व्हिच आई एम गोइंग टू एक्सप्रेस हियर? it is yeah, it is central force motion. Motion as a one body problem. That's what I'm going to do here, right? So consider two particles and say their mass is m1 m2. So this is a coordinate axis. And say we are having two particles, say one particle is this one, and say there is another particle, and that another particle will be here. And how these particles and what are their positions? This is one particle, and say this is another particle, and say these are the position vectors of these two particles. So say this is first particle, say this is first particle and its mass is m1, and there is another particle whose mass is m2, and say it is represented by r1 vector and this is represented by r2 vector, and say this is the displacement vector. So this is the displacement vector, or in other words I can say that this is the separation between these two particles, and the separation between these two particles, say it is represented by r vector, right? So two particles and say located at point A and B. The particle at A1 whose mass is m1 and the particle at point B whose mass is m2, and say it is represented by r1 vector and say it is represented by r2 vector, and the separation between these two particles is what? Is a r vector. Now how this r1 and r2 and the r vector are related to each other, and if I apply the triangle of vector addition, then r2 vector plus r vector can be written as r1 vector, because these are the two vectors which are taken in same order, and this is the third vector, and which is taken along the opposite direction, right? So sum of these two is basically it is the r1 vector. So what should I write down? I can write down it as a r vector can be written as r1 vector minus r2 vector. And similarly, let me show you one more thing. Say if this is represented by say r1 vector and r2 vector, and r is represented like this, then according to this diagram, this r1 plus r can be represented as r2 vector. So I can write down the r vector is r2 minus r1. So in different text, so you have to see basically that how you have taken the arrow, how you have taken the two vectors, and the third vector which is taken in the opposite vector, that is the sum of the earlier one. So ये चीज हमें ख्याल रखनी है, तो डायग्राम को हमने केयरफुली देखना है, राइट? मीन्स चीजों को रिमेंबर नहीं करना है, you just feel that what is going on. So this is a way that how r vector, and say according to this diagram the magnitude of this r vector basically is equal to r, and it is represented by r1 minus r2, it's mod, and say it is simply equal to r vector, right? And yeah. And then let me go further. Yeah. So now let me write down the equation of motion. How equation of motion can be written as? Say it is a central force problem. For the first particle, say Fr is a, let me go back first of all, yeah. So I am writing here, say this central force, basically it is represented by like this, and we sometimes write down it as a F R cap, because this force is basically a function of r and it is pointing along only one direction, right? So let me do one thing. Yeah, let me go next page. Now for the first particle, because under the effect of that force there is a acceleratory motion. So that means, say, due to the, or if I can apply the Newton's second law of motion or equation of motion. What are equation of motion for these two particles can be written as, so how it can be written, yeah, so how it can be written, say first particle whose mass is m1 and say whose acceleration is r1 double dot, and it experiences a, but on this first particle it is experiences a central force, and that central force is represented by Fr, say along r cap. R cap is basically in this direction, right? And similarly the second particle, it is represented by this one. It's basically Newton's second law applying here, and in this case again the forces can be represented like this, because if this particle is feeling some attractive force towards this direction, then this is experiencing the force of attraction in the opposite direction. So let me now couple these two equations. Now I want to couple these two equations. Let me try to couple these two equations. So what do we do to couple these two equations? So let us couple 1 and 2, because let us couple equation 1 and 2 because motion of two particles are connected through r vector, and that r vector is nothing but r1 minus r2 vector according to this diagram. हो सकता है कुछ टेक्स्ट में इसको r2 minus r1 करके लिखा हो, so वो r1 और r2 का exchange that depends upon the direction which you have taken. Also again recall, because it is a two-body problem. It is a two-body problem. Say this is first particle whose mass is m1, and this is another particle whose mass is m2, and say it is r1 vector and it is r2 vector, and say it is a line joining these two vectors. So it is a two-body problem, and if it is a two-body problem, let us recall the concept of the center of mass, right? Let me recall center of mass, and say this is the center of mass of this system, and say its position vector is represented by r vector. Then how this r vector, or how the position vector of center of mass can be written, this you have studied in your lower classes. So r vector can be written as m1 r1 plus m2 r2 upon m1 plus m2. So अब अपनी +1 +2 की बुक्स में सेंटर ऑफ मास का कॉन्सेप्ट देख के यू कैन रिकॉल दैट, राइट? सो ये हमारे पास एक्सप्रेशन आएगा. सो दिस इज थर्ड एक्सप्रेशन. अब हम क्या करेंगे? लेट अस रिकॉल दिस इक्वेशन नंबर 1 अगेन. सो फ्रॉम दिस इक्वेशन नंबर 1 व्हाट शुड आई डू? From equation 1 and 2 what should I do? Say from here acceleration of the particle r1 can be written as Fr r cap, and this m1 go towards this side, so that means it will sit like this. And similarly r2 vector, it can be written as 1 over m2 with a negative sign, Fr r cap. So from here I can write down is r2 double dot is equal to 1 over m2 Fr r, sorry, yeah, r cap. ये हमारे पास यहाँ से एक्सप्रेशन आ जाता है. सो व्हाट इज R1 एंड R2? R1 माइनस R2 अगर हम कैलकुलेट करना चाहें, लेट इज कॉल इट एज इक्वेशन नंबर 4 एंड इट इज इक्वेशन नंबर 5. सो यहां से R1 डबल डॉट माइनस R2 डबल डॉट, ये हमारे पास किसके इक्वल आ जाएगा? इट इज 1 ओवर m1 प्लस 1 ओवर m2 Fr and R double dot, right? And what is it? If I again recall reduced mass, 1 over mu is equal to 1 over m1 plus m2, means this is a way how the reduced mass of the two particles can be written as. So from here we can write it down as like this. So from here 1 over mu can be written as m2 plus m1 m2. It can be written in this way. So that means what is it? It is the reduced mass of the system. It is the reduced mass of the system. Oh, sorry. Yeah, I've forgotten this vector. So let me write it down. And another one interesting thing is that, say, as I have written as a r vector can be written as r1 vector minus r2 vector. So if I take its first order derivative, then it can be written as r1 dot plus r2 dot. And if I take its a second order derivative, then it can be written as like this, r1 double dot, minus will be here, minus r2 double dot was here. So using this I can write down this as a r double dot vector, and it is equal to reduced mass of the system, and we can write down it as a 1 over mu was here, and when mu goes to here towards this side, then it can be written as mu r double dot is equal to Fr r cap. So what is it? That means, and where mu is what? Mu is the value of this one basically, because we know that from here I can write down that mu is equal to m1 m2 over m1 plus m2, right? This we can use anytime. So that means now this equation and the equations which I have written earlier, what was those equations? We have written two equations, that m1 r1 double dot is equal to Fr r cap, and similarly it is and m2 r2 double dot, r2 double dot, it can be written as Fr r cap. In the equivalent of the opposite direction, these two forces are acting. So these are the equation of motion for the one body, and this is the equation of motion for the two body problem. Thus we have written two body problem into one body problem, right? And thus central force motion, what we are concluding, thus central force motion is a one body problem. And another very interesting thing which I want to share with you, that this is just a addition to this particular thing. Say once we know this r and r, we can again rederive r1 vector and r2 vector. So let me do one more thing, say that कि या आर वेक्टर जो था वो हमारे पास था r1 माइनस r2 वेक्टर, और जो कैपिटल आर वेक्टर था, दिस इज द पोजीशन वेक्टर ऑफ द सेंट्रल फोर्स, सॉरी ये सेंटर ऑफ मास, पोजीशन वेक्टर ऑफ द सेंटर ऑफ मास। सो ये हमारे पास था m1 r1 प्लस 2 m2 r2 ओवर m1 प्लस m2। सो यहां से मैं r1 को कैलकुलेट कर सकता हूं, एंड r1 कैन बी रिटन एज r2 प्लस r वेक्टर, एंड इफ आई पुट इट्स वैल्यू हियर, r1 की वैल्यू अगर यहां पे रख दूंगा तो मेरा जो एक्सप्रेशन है वो r2 की टर्म में कन्वर्ट हो जाएंगे, एंड r1 जो था वो एलिमिनेट हो जाएगा यहां से। सो r1 को एलिमिनेट करने के लिए मुझे क्या करना पड़ेगा, इट इज r2 प्लस r वेक्टर प्लस m2 r2, ये आ जाता है, एंड डिवाइडेड बाई m1 प्लस m2। सो यहां पे मेरे पास ये आ गया, एंड व्हाट वाज इट, ये यहां जाएगा, सो ये हो जाएगा m1 r प्लस m2 r इज इक्वल टू m1 r2 m1 r2 प्लस m1 r वेक्टर प्लस m2 r2। सो अगर हम इन दोनों को क्लब कर दें इकट्ठा, एंड ब्रिंगिंग दिस टुवर्ड्स दैट अनदर साइड, सो ये क्या हो जाएगा, इसको थोड़ा रीराइट करते हैं। यहां पे r वेक्टर था, ये कॉमन ले लिया, m1 प्लस m2 माइनस इसको यहां से इधर ले आए, ये m1 r वेक्टर हो जाएगा, एंड व्हाट इट विल बी, या m1 plus m2 into r2 vector. It can be written it in this way. So that means अगर मैं m1 m2 से डिवाइड कर दूं दोनों साइड को, से ये आ गया m1 प्लस m2 डिवाइडेड बाई m1 प्लस m2 माइनस m1 r1 डिवाइडेड बाई m1 प्लस m2। ये इससे कैंसिल हो जाएगा, और यहाँ पे हमारे पास r2 वेक्टर आ जाएगा। So that means this r2 vector can be written as r vector minus m1 over m1 plus m2 into r1 vector। so इस तरह से हम क्या कर सकते हैं, r2 vector को just a minute, it is not r1, oh it is simply r, sorry, let me, yeah, it is r vector, and yeah it is also r vector, yeah right। so ये हमारे पास वेक्टर आ जाता है, r2 वेक्टर हम इस तरह से लिख सकते हैं, राइट। देन अब मुझे क्या करना है, r2 वेक्टर आ गया तो मुझे r1 वेक्टर कैलकुलेट करना था, तो r1 वेक्टर कैलकुलेट करने का तरीका क्या था, so what is it, so now using this equation I can write down r1 vector। so what is r1 vector, ये जो r1 वेक्टर था इसको मैं लिख रहा हूं r2 प्लस r वेक्टर। सो r2 मेरे पास क्या आ रहा था, बिकॉज मुझे अब r2 को एलिमिनेट करना था, बिकॉज नाउ r2 जो था मेरे पास r और r की फॉर्म में आ गया है, तो मैं इसको बैक सब्सटीट्यूट यहां पे कर दूंगा इसी पर्टिकुलर इक्वेशन में। तो ये क्या बन जाएगा, r वेक्टर माइनस m1 m2 इंटू आर वेक्टर, ये मैंने r2 की वैल्यू सब्सटीट्यूट की, और ये मेरे पास जो था r वेक्टर आ जाता है, राइट। सो लेट अस डू लिटिल अलजेब्रा, जैसे हम थोड़ा सा अलजेब्रा करेंगे हमारे पास ये रिलेशन भी आ जाएगा। तो व्हाट इट विल बी, इट इज r m1 प्लस r m2 माइनस m1 r होल डिवाइडेड बाई m1 प्लस m2, एंड दिस r वेक्टर विल रिमेन एज इट इज। अब ये मेरे पास LCM आ जाएगा m1 प्लस m2, ये आ गया r, इसको मैं थोड़ा सा डिफरेंटली लिखने की कोशिश करता हूँ, बिकॉज या ये आर था, ये आ जाएगा m1 m2 माइनस m1r डिवाइडेड बाई m1 प्लस m2 प्लस r वेक्टर. सो इसको मैं लिख सकता हूँ r m1 प्लस m2 डिवाइडेड बाई, या इसको थोड़ा और सिंप्लीफाई करने की कोशिश करते हैं. ये आर वेक्टर को ऐसे रखेंगे माइनस, या इसको मैं पहले लिख रहा हूं, सो प्लस आर वेक्टर माइनस m1 प्लस m2, ये आर वेक्टर आ जाएगा. और यहां पे मैं इसको आर वेक्टर प्लस ये आर m1 प्लस m2 माइनस m1 आर वेक्टर होल डिवाइडेड बाई m1 प्लस m2. इट कैन बी रिटन इट इन दिस वे. मैंने इन दोनों टर्म्स को क्लब करने की कोशिश की और इसको नहीं छेड़ा. तो ये हो जाएगा आर वेक्टर प्लस आर m1 प्लस आर m2 माइनस m1 आर वेक्टर. सो इससे ये कैंसिल हो जाएगा, डिनोमिनेटर हमारे पास m1 m2 आ जाएगा. सो दिस कैन बी रिटन एज आर वेक्टर प्लस m1 plus m2 into r vector. So that means we can calculate now r2 vector in this way. So that means if r and small r is known to me, then both r1 vector and r2 vector can be written as. So that means our two body problem is converted into a one body problem, and the things which we have used the concept of reduced mass and the concept of center of mass there, and using that we can also predict the position of the actual particles which are which are experiencing central force, right? So that's all for this lecture, and in the next lecture I will talk about other things motion under central force. Right, here I will talk about the radial and the transverse equation. So thank you for watching this lecture,